In order for the Palo Alto firewall to have a fair chance of doing its job with application control, we need to give it the ability, if needed, to decrypt SSL traffic before it forwards that traffic out to the intended servers. And in this nugget, we'll take a look at the steps and the configuration to do exactly that. One of the challenges that we want to address right now is that this user, Bob, if we want him to have general access to Facebook, we know how to do that. We've done that in the previous nugget in setting up app ID and Facebook policies. So we can use Facebook base, and we can also set up specific applications like chat. And I'll tell you what, it's pretty amazing that the Palo Alto, up to this point in what we've covered, has done what it's done. And that's because a lot of these connections between Bob and Facebook are done with SSL/TLS using HTTPS. And as a result, the Palo Alto doesn't have access to the actual payload of what's really inside that encrypted traffic. Now, two thumbs way up to the Palo Alto firewall, because even though it's not seeing into the details of the payloads, it still recognized that the chat application was being attempted by looking at the initial setup of those connections. And before we had allowed chat to happen, it was denying that. And that's pretty darn amazing, considering that we have not yet given this Palo Alto the ability to decrypt SSL traffic so it has full access to the payloads in all the traffic it sees. And what we'll discover is that if a user has an existing SSL session and they're doing stuff inside of that existing session, for example, they're using additional apps and so forth, if the Palo Alto can't see inside of that content, it would be very easy for the user to sneak stuff past the Palo Alto firewall. So to solve that problem, we can play MITM, man in the middle. Now, usually from an attacker perspective, a man in the middle is a very bad thing. However, here, used in this application of outbound SSL decryption, it's a good thing. Because we can have Bob go out to the resources he wants, but we can stop that traffic. We can have our own SSL session between Bob and the Palo Alto firewall. Then the Palo Alto firewall is going to be acting as a proxy out to that final resource Bob was accessing. So we have an SSL session here and an SSL session here. And the beautiful thing is that the Palo Alto firewall has the ability to take a look at the unencrypted packets in the middle before he continues to forward them out. And then with App ID, with this beautiful Palo Alto firewall, being able to use its signatures and decoders to truly identify what the application is that's being used, can then enforce policy because it can now see all that traffic clearly. I can see clearly now the decryption's on. So here's the steps to set this up. We're going to create a certificate on the firewall. Now, we're going to use a self-signed certificate on this Palo Alto firewall. If we had an enterprise CA server in-house, we could use that as well to assign a certificate. Either way works great. We're then going to go to our user computers, including Bob's PC, and we're going to tell that PC to trust the Palo Alto certificate that we're using for the outbound decryption. And that way, Bob's computer trusts the certificate that the Palo Alto is using. And then third, we're going to set up a decryption policy that simply says, hey, if you see traffic that's going from in to out, and it's this type of traffic coming from this certain subnet and so forth, go ahead and decrypt it so we can take a look at the contents. And when we do that, that's what causes our Palo Alto firewall to act as a proxy between the users like Bob and the SSL/TLS resources on the outside that those users are trying to reach. So here in the graphical user interface on the Palo Alto, let's start off by creating a certificate, a self-signed certificate. To do that, we're going to select the device tab right here. And then over on the left, we're going to go down in our pick list under certificate management, and we're going to select certificates. To create a self-signed certificate that we can use for the purpose of this SSL outbound decryption, we'll simply go down here to the link for generate, and we'll click on generate. And let's name it outbound cert, and for a common name, let's call it Pan OS Firewall Cert. We'll click the checkbox for certificate authority. We can specify the cryptographic settings that we want. In security, usually bigger is better. So I'm going to currently leave the defaults here. And then for the certificate attributes, we'll click on add, and let's just do these in order. For country, it's going to be US because that's where I currently am. So we'll type in US, select US. We'll click add. We'll go to state. Currently, I'm in the state of Nevada or Confusion, one of those. And we'll also add locality. I happen to be in Las Vegas. That is my home. And let's go ahead and add one more organization, and we'll put in CBT Nuggets. And we'll click on generate. So now what it's done is generated a public-private key pair, and it's also generated this self-signed certificate that includes the public key. Also, regarding the certificate, before we leave here, I'm going to go ahead and select it, and let's actually edit this certificate. And regarding its usage, and here we're going to select forward trust certificate and trusted root CA. Let's also do forward untrust certificate. And if we failed to set up, for example, the forward trust certificate, and then we attempted to use this certificate as part of an outbound decryption policy, we would have an error when we go to attempt to commit it. And in the error message, it would tell you, hey, you don't have a certificate that's configured for forward trust. So it's basically do it now or do it later when the error comes up. But it needs to be done. So we'll go ahead and click on OK. Now, in this course, our focus is how to configure and work with the Palo Alto firewall. If you need a refresher or a brush up on the basics of things like the public key infrastructure and private public keys and digital certificates, I would invite you to check out the CompTIA Security Plus course right here at CBT Nuggets. And one of the cool things about the Nugget format is that you can go, pick and choose exactly the pieces that you want. For example, in Nugget 34, there's cryptographic concepts, and then cryptographic protocols, and then PKI, the public key infrastructure. Those 3 nuggets, if you want to brush up or get more familiar with the concepts regarding security and encryption and the public key infrastructure, I would encourage you to go watch those 3 nuggets from the Security Plus course. That's the CompTIA Security Plus course. And the same concept holds true for any topics that you want to learn more about and become more familiar with and better with, which could also include basic networking. There's also a CompTIA Network Plus course, which also covers a boatload of fundamentals regarding general networking. So please feel free to leverage any courses here in our CBT Nuggets library as you continue to learn and watch and practice and get really, really good at these technologies. So step number 1 is done. We have created a digital certificate on the firewall, and we've set it up as a forward trust certificate. Our next step is to go ahead and tell the clients that the certificate is trusted. Now, to do that, we're going to need to get the certificate off of this Palo Alto firewall and onto Bob's machine. So the actual file itself could be shared on a network file server, for example, or you could put it on a thumb drive or some other media and get it over to Bob's computer. And in my lab environment, here's what I'm going to do. In my lab environment from Bob's PC, I'm actually going to log on to the Palo Alto firewall as the administrator. Now, Bob himself, of course, wouldn't be doing that. But we're going to do that because once we log on with the graphical user interface, we can go ahead and simply export that digital certificate right to Bob's computer, and then we can go ahead and import that as a trusted certificate on Bob's computer. So I'm sitting at Bob's computer and I cannot get to the management IP address from Bob's computer, and it just occurred to me why that is. That's because when we did the Facebook security policy, we disabled the other basic web access, which included web browsing and SSL outside of Facebook. So we need to go back and modify our policy on the Palo Alto so that Bob can get access through the Palo Alto. So let's do that. Let's go back to our original management session on the Palo Alto firewall. And here it is. And we're going to go back to policies. And over here on the left-hand side, we'll go to security. And sure enough, users going to internet, we have disabled. So let's go ahead and select that. So it's highlighted, and I'm going to click on enable. Also, I don't want to have that as my first rule, so I'm going to drag it down to make it the new rule number 3, users going to internet right here. So that's allowing the basic internet group applications, which are, let's go ahead and use the down arrow here and hover over value, SSL, DNS, web browsing, and ping, which will be great. That's enough that Bob can go ahead and use his browser to get to the management interface on the Palo Alto firewall. So we'll commit these changes, click on commit again. I'll go ahead and close that. We'll let that happen in the background, and then we'll go to Bob's machine and we'll try once more. So we'll click on refresh here. Now it's giving us a little bit of grief regarding the certificate, but this is just because for the SSL session for management, the Palo Alto firewall is also using a self-signed certificate, and that's why Bob's browser is having a little bit of grief with that. So if we click on advanced, we're going to do something we tell our users never to do. We are going to proceed to that website of .222, which is the management interface on our Palo Alto, and we'll log in as admin. So we've supplied our lab password, pressed enter. And look, this is interesting. On the dashboard, it says we have 2 people logged in as admin. We've got somebody logged in from .92, and we've also got somebody logged in from .250. Now that's interesting and exciting because the .250 address is the address assigned to interface 1/1 on the outside. And the reason that the Palo Alto firewall sees us coming from that address is because Bob is going through NAT through the firewall, specifically port address translation. So that is the translated IP address before we access the management interface at .222. So in any event, there was our original session, and here's our current one that we're now looking at. So that's cool. And let's go over to Device, the tab on the far right. And on the left, we'll go down to Certificates. Here's our certificate, so we'll select that. And what we're going to do is we're going to export this. So to export this certificate, which we want to import on Bob's local computer, we simply use the export hyperlink here at the bottom. So we're going to export it in base64 encoded PEM and click on OK. We don't need to export the private key. We want to have that backed up somewhere, but we don't want to have the private key sitting on Bob's computer. So we don't need to export the private key. In fact, we wouldn't want to if we were going to import this over on Bob's computer. So we'll go ahead and leave the export private key unchecked. Click on OK. And down here at the bottom left, it just downloaded that called cert_out-bound-cert.crt, that file. So here in Bob's browser, and he's using Chrome, we'll go over here to this icon to customize Chrome. So we'll click here, and then from the drop down, we'll go down to Settings. And just because it's probably the easiest way to find it, we're going to type in certificate. And this may vary a little bit based on the browser that you're using and maybe future generations of Chrome. But this is a fantastic way, in Chrome at least, to find the certificate management section. So here we'll click on the button that says Manage Certificates. And then we have Personal, Other People, Immediate, and we have Trusted Root Certification Authorities, or CAs for short. And there's a nice list of certificate authorities that this firewall currently trusts. But one of those is not our Palo Alto. So if we want to import a certificate as a trusted CA certificate, all we need to do is click on Import right here. This brings up the wizard. We click on Next. We click on Browse. And then there in our Downloads folder is our cert_out-bound-cert, which was the exported cert from the Palo Alto. So we'll click on Open. Click on Next. Because we started on the tab that was called Trusted Root CAs, or Certification Authorities, that's the default store that it's going to place it in. Or we could also click on Browse, and we could browse the various stores. So we definitely want it to be in Trusted Root CAs, so we'll make sure that's selected, click OK, and then we'll click on Next. It's giving us a brief summary. We'll click on Finish, and now it's saying, whoa, you're trying to install this certificate, and we know we're doing it on purpose. We're going to click on Yes. It says the import was successful, and now if we go through our list of trusted CAs, we should have, there we go, the Pan OS Firewall cert right there. And we'll click on Close. And then we can close this browser, and we can also go ahead and log out here from the Palo Alto interface, because we're no longer going to need it from Bob's PC. Our last step is to set up a decryption policy that says if traffic is being sourced from the 10.1.1 network and coming in on an interface on the inside and being routed out the outside, and if it's going to certain categories of websites, then go ahead and decrypt that traffic if needed. And the reason it's important to have conditions there as far as certain types of traffic is this. We don't want to do decryption if somebody is really going out to, for example, B of A, Bank of America, or PayPal. So the reason that's a little bit dicey is because if we start decrypting that traffic, we now have exposure and risk regarding being responsible for having looked at that data. So if Bob, the user, is allowed to go to PayPal and we're decrypting his data, we could have some liability there, as we can see that unencrypted information right here on the Palo Alto firewall. So for our demonstration, let's do this. Let's go ahead and set up a decryption policy that only decrypts traffic that's destined for Facebook. And that way, it won't hit financial types of sites like Bank of America or PayPal. It'll just do Facebook. So we can be very granular as well as far as which categories of sites should be decrypted for outbound SSL decryption. Now, back at our interface here for the administration, under Policies, on the left-hand side, we are going to select Decryption. By default, we don't have a decryption policy, so we'll create one. So we'll click on Add, and we'll call it Outbound-SSL Decrypt Policy. And the source, we could go ahead and say we want the source zone to be inside, and the source address we could add as Bob's specific subnet if we wanted to. We haven't got into user ID yet, so we'll touch that later. Regarding the destination, we'll go ahead and specify we're looking for traffic that's being routed out the outside zone. And regarding the destination address, we don't care about the actual IP address on the internet. But we do care about the category of type of site it's going to. So this next tab over here on the right is service/URL category. Now for service, it says any. So for the service, it's very likely going to be TCP port 443 that we're going to be decrypting, but we can just leave that as any. Our focus here is the URL category. So instead of saying any category, for example, banking sites, entertainment sites, gaming sites, social networking, instead of saying any of those, let's go ahead and click on add. And just reading this list makes me a little bit nervous. So let's go down here and let's specify social networking. So with this policy, with this URL category, we would expect Facebook to be subject to the SSL decryption, and other sites like finance, such as Bank of America or PayPal, they would not be subject to the decryption policy. And then if we take a look at the final tab, which is options, we want to say action decrypt, and we want to specify SSL forward proxy, because we want the firewall to decrypt the SSL session between Bob and the Palo Alto firewall, and then act as a proxy on behalf of Bob out to the final website that Bob was trying to reach. So we'll click on OK, and then we'll commit those changes by clicking on commit, and then we'll click on commit once more, and I will click on close and let that finish in the background. Also, it's really important in testing, especially if you're on a little PA200. In the early days, like in the 80s, when the IBM PC first came out, it was counting up RAM, up to like whatever, 16K or 64K. And then when they got to 640K, it would just take so long for that count, and it was painful to watch. But in testing, especially with a low-end firewall like a PA200, you want to make sure that anytime you do a commit, you just make sure that it actually completed successfully. And if it didn't, go back and resolve any dependencies or other issues that came up before you start testing, because it can be very frustrating if you start testing and it's not working and it's because the commit was never successful. So I'm going to go ahead and verify that. So the commit looks great. We'll click on close, and let's bring out Bob's computer. So here's Bob's computer once again. Let's open up a browser and let's go to facebook.com. So that appears to be working. So I'm logging in with my username and password. So because we have Facebook base as part of our policy and Facebook chat as part of our policy, those features should work. And the question might be, well, now if this is really using SSL proxy, how does the user verify that? Well, one way would be to go to point to this little lock up here in the URL next to HTTPS. We'll click on that. And then if we go to the sub-tab of connection, and based on your browser, it might be in a slightly different location. But it says right here, the identity of this website has been verified by PanOS Firewall Cert. So that is one way from a client perspective that we could verify that the SSL outbound decryption is actually working. And if we contrasted that, if we went to another site, let's go to another site. Let's go to paypal.com, and that's redirecting us over to HTTPS. Fantastic. And if we click on the lock here for PayPal and go to connection, this certificate has been verified by Semantic Class 3 EV SSL CA. So that's the actual certificate authority that issued the certificate to that PayPal server or system that we're now connecting to. So for our assessment, I'd like to do this. We have 3 basic steps that we went through to enable outbound SSL decryption. Those steps, before I blurred them out, were right there. And what I would encourage you to do right now is pause for a moment and just verify that you can logically remember what those 3 steps are. If you need to back up a little bit, review those steps to make sure you know what they are, that would be perfectly fine. I would also encourage you, if you have the ability to do the hands-on practice in setting up these components, I would also encourage you to do the hands-on practice wherever possible. I am glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.